This is a video just going over the couple of problems that were different on Quiz 2 version 2 than Quiz 2 version 1. So namely number 1 and then number 3, the two graphs. But for all the other problems, please look to the video on Quiz 2 version 1. Okay, here we go. This first problem, finding the inverse of a function that has a restriction. And again, it needs a restriction because the original function isn't one-to-one. In order to be invertible, you need that one-to-one correspondence. Every x value has to go to a unique y value, and anything that involves something squared, a variable squared, will not be one-to-one. So it needs a restriction. Okay, so there's a singular x, so I'm gonna find the inverse by undoing the original function. So to get the original function, added 1 squared, multiplied by -1, added 4 square root, multiplied by -5, and then added 1. So we're going to completely undo this. So subtracting 1, dividing by -5, opposite of square rooting is squaring. Subtract 4, divide by -1, and when I do, I'm going to now switch this around. Dividing by -1 means I have 4 minus x minus 1 squared. I'm going to square the -5 and make it 25. Okay, the opposite of squaring is either the positive square root or the negative square root. And then to figure out which it is, you want to look towards the domain restriction of the original, because this will be the range of the inverse. So the range of A inverse should be -3 to -1. And in order for the inverse to have only negative outputs, I'm going to have negative the square root. So my A inverse of x will have negative the square root of all that, and then the opposite of +1 is -1. So notice this inverse also has a variable quantity that is squared. So it too will, in order to have an inverse, it too will have to have a restriction. And to find what the restriction is, we're going to look to the range of the original. So the range of the original function, so this is the range of A of x, -5, the smallest coming out of that square root will be 0, and the biggest will be the square root of 4, or 2. And multiplying both of those by -5, I'd get -10 to 0, and then adding 1, it'll be -9 to 1. So my domain restriction for this inverse will be for x being between -9, whoops, let me erase that, that looks messy, between -9 and 1. And so this whole thing is your inverse. Okay, so the other unique problem to version 2 are the graphs. So let's go there. All right, there was a typo that I fixed before I copied. This should be -2 in both of them, which I wrote on all your pages. Okay, so here, the transformation is, always do the domain transformation, the transformation x first. So this is saying, if we think of x plus 1 between the extremes of the domain, I'm subtracting 1 or going left 1. So that's the domain transformation. Oops, left 1 would be -6, not -4. Okay, so let's do that point by point. So I'm at -6, and I'm just going to take these kind of crucial points here. And this one will be here. Okay, so my new graph with just the domain transformation looks like this. Okay, and so now it says to the transformation in y is an absolute value. So it's saying every y values that are 0, or positive are going to be exactly the same. So I would mark those. And then any negative will come up as positive. So let's do that. Oh, I just noticed an error here. Let's fix this. Hold on, I'm going to try to erase this. Oh, Lord. All right, maybe it's not allowing me to erase. I just noticed when I shifted left one, this point should be here. So let me redraw when I shift left one. Sorry about that. That should look here, and then left one right, and I don't know why I accidentally did that. And so the blue one is left one. Sorry about that. Okay. So now let's go to I'll do in green with the absolute value and y. So everything on the x-axis or positive gets marked, and then negative y values become positive. And then this negative 5 goes up to positive 5. And this negative 2 goes up to positive 2. All right, so your new graph should look like that. Sorry about the confusion when I messed up when I went left one with that one number. Okay, so there you have it for the part A. Now part B. So I find it helpful to put the domain transformations between the extremes of the domain, which again will be -5 to 7, because that's going to help us figure out the order we'll do these transformations. So the first thing we're going to do is left 2. So we'll be going then from -7 to 5. So let's do each of these left 2 to start off. So left 2, each of these kind of crucial points. 1, 2, let me make this a little bigger so I can see what's happening. And then left 2. Okay, so with just left 2, we'll do this in red. Actually, let me erase that for a sec. Oops. Okay. Okay, so that was left 2. And then we're going to mirror across the y-axis. That's the next thing. So now I should be flipping the x values across that y-axis. So it will be -5 to 7. Let's do this in blue. So this rightmost point will now be at -5, -2, and then we'll be at -2, 0. This point here will stay the same on the y-axis. And then we'll be over here, and the last one here will be at 7, and then up at 4. Okay, so got something like this. Okay, whoops, that stops right there. All right, now the last thing we're doing is the absolute value in x, which means everything to the right of the y-axis stays the same. So I'm going to do this in green. This stays exactly the same, and it gets mirrored onto the negative side. So the final graph should look like that. So and there's no, notice I didn't do the only transformations were in x. There were no range effectors in this case. Okay, so that's it. So for the rest of the problems, please look to the video for Quiz 2 version 1.